Hey, Frozen, what's up, dude? Sorry, I'm running a bit late tonight. I had to help my mom with some stuff. All right, just getting the lab spun up right now. Oh, I forgot my Jocko drink. I gotta grab that. Be right back. Act Smarter, what's up, brother? Happy Saturday, man. The one, the only, the famous, infamous? You decide. Oh, yeah. Get the Jocko out. All right, I'm getting HackBot's test lab run set up right now. If I can get it to work. I'm going to try my best not to cough into the microphone. I'm still getting over that. All that junk. And then poor Agent Zero, he caught a stomach bug and has just been sick and running to the bathroom all day. Poor little guy. All right, let's see if this works now. I'm curious. Are we going to get the green screen again? Nope, we're not. Oh, there it goes. Okay, that finally caught up. Let's see. that should that should have already been on. It should boot up with the system. All right, hang on. You have to be kidding me. All right, what's going on here? That's all right. We're just gonna let Stinger do its run real quick while I figure out what is going on here. All right, well, that is unfortunate. That's all right. We'll let Stinger do its initial run here while I try to figure out why the camera's not working. Let's see here. What is going on with this? Everything has to break at just the wrong time. All right, that seems to have fixed it now. Oh, the colors are all jacked though. Hang on 1 second. Why you do this to me? Like the colors are all kinds of... Okay, that's the best I could do for now. Let me see. Did it show up? All right, hold on. So the colors are all jacked up. That's all right. I need to fix them anyway. But watch this. This was the crazy part. Let me see if I find it real quick. This is what it looked like. So I had to bypass the Elgato software. But when I had the filters on, I'm like, I got a pink beard. It's kind of funky. That's all right. We'll just stick with this for now. All right. Well, good news is, looks like we got all the way to the exploitation agent before it died. So let's go check it out real quick. Apologies for not being able to stream last weekend, guys, but man, I was just dead. I was in such rough shape. Go. Make sure everything's up and running. All right, how far did we get through here before we hit an error? Hack that planet. Oh, actually, I think this was where we left off. Hack that planet, indeed. It's a meta hack the planet. What's up, brother? Actually, why did this error out on the step processor? What are you doing, step processor? Oh, right. Actually, I believe the problem here was because how we were taking data back from the special agent. Yes, we need to go back and remodify the special agent because it's finishing up in here, but it's overwriting data in... It's overwriting data or the wrong data in the state table. All right. And actually, hell, let's take a look at something real quick. So here's the current flow of this. So here's where the issue lies. Well, beforehand, what we were doing is we were letting this guy, or this node right here, the special agent node, which invisibly forks off to another graph that goes and executes and does everything, and let the special agents modify the state table. I'm thinking actually what I want to do is put one more node down here to handle the output from the special agent node. Or actually, we could just build it into the special agent node right here. It's a very trim node. And basically have the graph return some information to us and then handle that ourselves. I don't know how I want to handle that. I'm of two minds about it. The idea for remember, the idea for the special agents is they're supposed to be plugins, right? So the browser is like a plugin. So it has a full Playwright, MCP, headless browser that it can go through and work with. So the question is, do we want to give the special agents the power to directly modify the state, or have them return some information that we then parse out and then we modify the state? What would be the best way to go about that? I'm more in favor of... I can see a couple ways of this happening, though. So the benefits are... Let's pull up the old whiteboard of knowledge here. Let's clear it out. Let's think about this. So basically what we're talking about is whenever we call a special agent, right here, right? It's got to return some data back to us. So from our data, the question is, do we handle parsing that data or do we let the special agent do it? So we'll say, do we let Stinger do it, where it's got to get everything into that state table, or do we let the special agent handle it again? So the special agent actually handles the updates to the state table. So the question is, one of the problems I can see is, let's say you've got multiple special agents, right? If I could see like one of those special agents modifying the state table and in an unexpected way, and then another agent coming in and clobbering it. So I'm more akin to this method. So with this one, what we can avoid is we can avoid clobber. Basically not having it gum up the state table. Also, the idea, though, is that the special agents are only supposed to be able to handle tasks, right? In this case, it's an exploit task, but it is a task. So whether it's a primary task... Actually, no, I take it back. Primary tasks are only handled by... they're only handled by the primary agents. So this would be some kind of like a subtask. Basically, using it as a tool. If that's the case, if the special agent is a tool that's going to be used by one of the other primary agents, right? I think I want to go with this method here. We tell the special agent it needs to basically return output back, and then we append that into the state table. So that's going to go to the state. So I think this would be the better idea for it. So let's try that idea. So what we're going to do is we're going to edit this node here. Let's see. Because right now the problem is... So actually we'll have to make two modifications to this. We'll have to go edit the special agent itself and change and format how it's actually making those updates. Ooh, how are we going to do that? That could be... Actually, we have fields for that. We have fields just for that we're not using. Or we could add one. We could actually put that in the working memory right there. So yeah, what if we did that? We have the special agent return its information to the working memory of the state table. And then our special agent node gets the information back out of the working memory and puts it properly into the state table. I think that would work. Okay, I'm going to leave the browser agent for just a second. Let's go back to the exploit agent and go down to... Where's our special agent node? There we go. So rather than just returning the response directly, actually, we won't even have to do that. I take that back. Because the way we're invoking this, since we're not invoking it directly from the graph, it actually doesn't need to return a bunch. close the browser. Let me close some of this stuff up here. I got too many windows open. Stinger, tasking, context helpers. There we go. So currently what we have it return whenever we have the browser wrapper fire, we have it return this structure right here. Yeah, so here's what's happening. Right, we return to this structure back into here. And then when we have this come back, we're basically just taking that and directly slapping it into here. I'm trying to alt tab and I'm failing hard. Here we go. Yeah, I think that's the better. Actually, this works really easy because what we could do is, rather than putting all this stuff into here where we have it doing all this extra state table management. Let's see what we can do. And man, I hope this is really going to work. So I actually took I told you all about it. I took a class with Jason Haddix 2 weeks ago, and it was really cool. It was his red, blue, purple AI course. Had a really great time with it. I was having a lot of fun. Actually was able to put some of the stuff into practice on a current penetration test that I'm on. So I definitely wouldn't have tried this on a red team, but since it's a pen test, we have no expectation of stealth from the client. I decided to go ahead and try it, and I actually had to do some really cool stuff. I tested it out, I checked the code, make sure everything was copacetic, and had it modify Impact so where I could go pilfer a bunch of files off of an SMB share. They had open SMB shares like pretty much every company does. We go through, we pilfer the files down, but then also I have a Nemesis server set up. So I wanted to be able to get all those files over to Nemesis relatively quickly. So then I actually made a Claude Code skill to get those up to Nemesis. And it kind of works. It's very janky, but it was a cool proof of concept for me. So I'm still working on it. Then I found out there's a really weird thing that happens with Claude Code a lot of times. So whenever you're storing this stuff up in there, so Claude Code has kind of like a master config located. It's in your home directory in .claude, right? And then inside there, you have a whole bunch of other directories. One of those is your skills directory, which is essentially a markdown file and any other scripts that you need to enable it for prompting and whatnot. But what's funny is this should load like universally as soon as Claude loads up. There's a bug somewhere in the Claude code where it just doesn't load those skills up. I have to go directly tell it, hey, go load that thing. Here's where it is. Do your thing. Nada. until I manually tell it. So a couple of bugs aside, a couple of hitches, it actually was working though. And it actually did do it. Since we've got very precise token tracking, this wasn't using like a public instance of Claude. This was using what those Chinese hacker scrubs should have been using whenever they were trying to do their ultra elite nation state hacking. And it's tied to a private instance of Bedrock. So I'm using that as the backend for it. But as this whole thing's going on, I saw that I burned like $20 in tokens in just a day of working on it. And I wasn't really pushing it that hard. So I was like, I'm gonna have to talk to my boss. I'm like, hey, I need a budget increase. Which I don't think will be a problem because it's budgeted for, I think, everybody on my team, and not many people are using it to that extreme. So I think I can say, hey, can I just get a little extra share of the pie? Can I get seconds? Let me take a look at this real quick. So all right, so here's how we're returning the information if it's an exploit task. Actually, if we're going to be just returning everything like kind of nicely formatted, Excuse me. What we can do here, we could actually take all this stuff out. All of this could go away. Because we won't need to separate it by exploit tasks or anything else. Pretty much what we can just do is return this section right here. Oh, no. Copy. Let me double check this real quick. Where did we actually do the invocation, though? This is checking for it if we have agent tools. Let's see. So we turn all of our agent messages. See how I want to do this. Let me scooch this over a wee bit. It's been a bit since I had to dig into the browser agent. Let's see. So we get our session name. This is checking if we already have a browser session open so we can reuse it in the future. We build our task. We actually don't even need this part either. This part I think I do need, though. This is the part actually we need. Here we go. That gives us our exploit task index. This is our browser task. Let me close this. There we go. Here we build the context for it. If it is a exploit task. Okay. I take it back. We actually may want to leave this code in for just a wee bit. And then move this part down here. Because and the only reason for this is because we want this additional context to come through in the exploit. Right here. Here's where we edit it to the scratch pad. Hold on, let me go take a look at the... Well, I thought we'd already fixed this. Let me look at the trace again real fast. So down here, it should return the summary of everything that it did. Navigate to the panel page, which is good. It should have done two things. So we should have got their PHP artifact, and then we should have gone to the... navigated to the page. Actually, yeah, this should have worked just fine. Because, hold on. We'd actually... No, this was the first invocation of it. Okay. Let me take a look at this error again. I got to dust off the cobwebs. I haven't worked on it in 2 weeks. Let me see. So why is it saying there's no steps in there? Hold on, so here's all of our input. Exploit step update, no tool call output found. Oh, it's because it doesn't see it as a special agent. Oh, let me think. Gotta unwind the ball of string here that I've created. Let me see if the reviser actually looked at it. Oh, is it this part? Hold on. Did it only return an exploit task? I think that's actually not correct. Hang on. Let me go through the whole exploit agent. Let's see what it does here. So there's Stinger. Here's where we actually enter the exploit agent. So once we're down in here, exploit does its thing. Planner. What did Planner come back with? Okay, get the artifact, go to the panel page, upload the web shell, check for it in uploads. Let's see, access the upload PHP, and then test to confirm that it's running by doing who am I or ID. Excuse me. Okay, so it calls our get web shell artifact, and then what did the revisor come back with? Here's the issue right there. See that? So the revisor came back with all of this from the input, and it should have just modified this particular one first. There's the scratch pad, right? It says, yeah, we've got our PHP artifact. And let's see, it should have the full path in here. Well, actually, it's fine because it updated it to validated, so that should be good. For some reason, this one's iteration 0. So one thing we did is we shifted a lot of the responsibility for tracking all of this data over to the language model. We decided to shunt it over to it because as we were trying to make the scaffolding for it, it was making too rigid of structures. So we wanted to be able to utilize some more of the intelligence for the language model. So we backed out the structures and are giving it a bit more raw input and output, giving it a tiny bit more agency. Don't want to give it too much. All right, so here it calls the special agent. So why did the revisor... I think this might be the kicker here. We had to go look at the state table. What was the input output looking like from this? Because it only returned a small fraction of it. See that? So up here, the revisor, when it returned the entire structure like it's supposed to. See that? Returns the entire structure of the exploit task. But for some reason, down here the revisor only returned a small stub of it. So we sent it the entire exploit task. Let me look at the exploit router real quick. Let's take a look at the actual exploit task that's happening in here. Yeah, see right here? So look at this. The only thing we've got in here is we have a status working this. We don't have any of the steps. We just have current step happening right here. But if we look at the input state table to this, actually we'd have to come up here. And so this is what's happening is we're losing fields for some reason. It's completely overriding it because it only returned that stub. Shut up, baby. I know it. What's going on here? Hey, monkey. What's up, dude? What's crack-a-lackin'? This is very odd. Well, let me back it up a bit here. Let's go back up the chain a little bit. Let's look at the input for this one. See, look at this. Here's all of our steps. For some reason, this is our input state. We have everything going over to the scratch pad. That's perfectly fine. And does this match the output? Well, output was just that. No tool call output found. Okay, so it didn't have to go through any of the updating process because it came from the special agent. So hold on, where does this come in at? Look at this. All the steps are gone between here and here. Why is it showing that as the input and not the output? Yeah, see that? That's weird. So I like the idea of what it's doing. I just don't like what it's actually doing. For some reason. Gotta figure out why it's clobbering that or where it even is. So here's the input for the browser agent. And when the browser agent gets it, what do we get? All right, we have all the steps right here. Boom. Looks good. So if we look at the output, hold on, let me collapse these down. Yeah, all the steps are still in here when it comes back from the browser. So this is the, excuse me, freaking cough. It's just plague season in Texas right now. Yeah, so when this is our output right here. It comes back, boom. We still have all the tasks in here. Collapse these down here. So where's the change actually occurring? Okay, all the steps are still here at the input to the step updater here. So then let's go to the reviser. So when the reviser fires, where do we go? Let's see. So something's happening in the exploit update step here. This is hella weird. I had my first pass at building a RAG with LangChain last weekend. Nice. I got a renewed hatred for PDFs. They're now like the pile of elements in a trench coat acting like a file structure. Dude, PDFs are like the most unstructured of structured. They're structured in the same way, like if you were to take like a bunch of, like, you take a giant container, right? You go down to a beach, you just scoop a big raw bucket of sand in there. It's not sand, right? You got seashells, you got broken glass, you got rocks, you got seaweed, you got phytoplankton, and whatever other crap you find at the beach. And there's sand all around it, right? It's completely unstructured. Yeah. I was actually just looking for something to try and help with automatically annotating PDFs. And hadn't really found a good solution for that because they're so freaking unstructured. So yeah, something has to be busted in the exploit step update. So let's go look at that code real fast. There's the step processor. Here's our special agent node. Take that out. Let me clean up this code a little bit here. We're not even using this exploit step here. Probably just breaking the crap out of everything right now, but that's fine. Okay, so the last message is tool message. It's gonna do that. Actually, I want to do another update to this because currently initially this section of the graph wasn't here, right? It went immediately to from the processor to the tool node to the update. So actually, let's look at this step router in here, and we can use that same logic down here to kind of verify that a special agent was called, and we can look at that real quick. But why would this? This one didn't even return any tasks, though. I don't get how that would have happened, because literally all it's doing is returning this one thing. I tried an unstructured lib, I tried PyUpFD, but it's all different ways of polishing that turd. Yeah, no joke. Pretty much, I think almost the only thing you can do with PDFs is convert them to images and OCR them real fast. Hey, Binek, I don't know what the font command is, but I tried to make it so it's large enough to be readable. I can make it bigger. That's what she said. And my wife just yelled, "That's not what she said." Let's see here. What is this song? Drop the Act? I need to get rid of that one too. My desk is a mess right now. Let's see here. So here's all it's checking. It's checking to see if there was a tool call made. It's kind of jank, but you know what we could do is actually we could put a global variable in here to be like last tool called. And we could actually use that as part of tracking. So it would be nice to like double check everything in the state table. Let me think about this. So here's what I'm thinking. Let me put a marker right here just so I remember what I was doing. And that is, we come up here. And what we do is we just put a placeholder in here. Yeah. Do this. Last tool called. Make it a string. And right now we're gonna make it we're just gonna make it blank. Then what we'll do is we'll come down here. And whenever the router hits this, what we're gonna do is we're gonna set that. So we'll say the last tool called is gonna be that. Now undo that. Killing me, Smalls. There we go. Will that not use the outer scope for it? Or do I need to use it maybe? Oh, I don't know, actually. Come to think of it. No, that should be fine. We should be able to access that from in there. That's it. Let's do it this way. We'll modify it to be this. We're going to say the last tool called is going to equal... No, damn it. I screwed it up. Take this. There we go. And then what we'll do is we'll just check that value right there. I don't want to rename it. I want it to be that, though. I want to have a global variable. Take that out. There we go. So now let's double check what's happening here for the step update. So hang on one sec. I'm trying so hard not to cough into the damn microphone. Oh, just know the font's name? Dude, I don't even know, man. Whatever PyCharm uses by default. Let me see if I can find it here. Hey, Burnell Codes, thanks for coming online, man. Welcome in. I hope you're having a fantastic Saturday. I had an okay one. My oldest son, codename Agent Zero, woke up with a stomach bug and was just sick all night, all day. And hopefully he'll be able to sleep tonight. But other than that, we just, because the kids were sick, my wife and I are still not feeling great. We just hung around the house, put up the Christmas tree. Which was a really nice thing to do because today is my sister's birthday. And she passed away about a year ago. So it was, and she would always come over to like put up the Christmas tree with us. So that was something nice to do on her birthday. Let me see. Editor. Hold on. Font. All right. This font is literally called JetBrains Mono. Make it a tiny bit bigger. Yeah. I don't usually get too hung up on whatever the font is, so long as it's a monospaced font. If it's not mono, it's crap. Hold on, let me go add some time to the try hack me box real quick, so that'll get us through the end of the stream. Oh, come on, man. All right, I'll just have to get a reminder in 15 minutes. Let's see here. All right, so now we should be tracking what the last tool called is externally. There's our special engine node. There's our exploit step updater. All right, let's take a look at this. So I think what we're going to do is we are going to check if the last message was a tool call, because that'll tell us what we need to do on there. But we're going to add another else here. So let's do a elif if last tool called is special agent. Is that what special agent caller. There you go. So if the last tool called is special agent caller, we're going to do one more thing here. We're going to still return this, but AI message is, let's see. Let's see. Last tool called was a special agent. There we go. We'll have a little bit extra telemetry for this. I don't get why this would... Because this shouldn't have been clobbering anything, because in the trace we saw update being called multiple times. It gets called after every step. After every exploit step it gets called, right? So here's the first one. It does just a call to the server to get the PHP artifact, which is our web shell. And then after that, we call update. Let's see. I'm trying to think what's the best way to handle this. Some of the information is not quite grokking in my brain, because it makes no sense where the collision is happening. So here's what's happening. Let's go back to the graph and look at this real quick. So when we initialize this guy, we pull this stuff over here, right? So it enters the exploit agent. It comes down and starts executing in this loop right here. So the planner goes through and says, okay, here are the steps we're going to need to do to accomplish this exploit. The processor then says, okay, I'm going to start with the first. I'm going to see if I have any tasks that are working. I'm going to work on those first. Excuse me. Otherwise, I'm going to start with the very first task in the list, the very first step in the list. It comes through and says, okay, I'm going to analyze it. I'm either going to call a tool or I'm going to call a special agent. Calls a tool, then the tool returns its data. The update node here says, all right, I'm going to handle putting all that information into the state table, handle it to the revisor. Revisor says, okay, good. And then it comes back into here. So there's something breaking along the lines when it's going down this path right here, from the special agent node to the step update. But what could it be here? So if the last message called was a tool, then it needs to return this information here. And then if it's we just added this part right here. So we're just going to double check if the last tool called was a special agent. In this case, we're just going to pull the information directly because we're going to need this last message information. So it makes sense to pull this out again. As we come through here, though, this would just say, okay, last tool call was a special agent. That's totally fine. And then here, we'll say this return is just in case for some reason there is no tool called, which that never should be the case. This loop is designed to only handle that. This is a weird one. I might just go try rerunning it from scratch, like as is. Maybe we hit an odd corner case. Let me start it over. So it should get through the first iteration just fine because the first thing should always be go get the web shell. And then the second one should be typically calling the web browser to go navigate, to spin it up, instantiate it, and then get it over to the target site. Actually, this just reminded me of something. Something that one of the guys, when I was doing some reading, so right now it should be having the web browser go through and do it. The revisor's doing its thing. And it looks like it still returned that stub piece of information. Yeah, errored back out on the step processor. Because it's trying to find the steps key in the exploit task, and it's failing. Something's clobbering it along this path here. Checking on Peaches. Peaches is sleeping under my desk. That's my Boston Terrier. And she was making little whimpery noises. She must have been having a dream. For being like a complete and absolute indoor princess, she still has like all of her hunting instincts. When I took her to Oklahoma over the summer for vacation, we stayed at a cabin out in the woods, and it was real nice. And I take her on walks, and she'd see like a pack of deer, and you could just see like the urge to hunt intensifies. It was hilarious because she weighs 25 pounds soaking wet. Let me see if I can bring this over a little bit so we can examine this as we're kind of walking through it right here. So where was this? Okay, here we go. So up here somewhere is where it's getting clobbered, and I'm pretty sure... Is it not going to let me see the state table from here? So we had 2 LLM runs from this one. I guess not. I wish I could just have it auto-collapse everything. So like, I don't care about these nodes here. Collapse, collapse, collapse. This is the first step through the processor. And in this case, the revisor actually came back with everything that needed to come back. Current step, steps, boom. Okay. And then the step processor goes and actually invokes the special agent. Did it not load up our... Because it still says no cool comment found. Hang on. Why did you not hot load our changes? Yeah, let me back this up a bit. Alright, so there's where the error happened. So then it said it couldn't find steps. So it looks like it did load it. I wonder if this global variable is just not getting set correctly. Damn it. I thought that would work. So the way this is happening is all this information is being compiled into an object and then being passed somewhere else to work on it. So it's actually not running inside this script. So that makes sense why the global variables aren't working. Damn it. If I really wanted to do that, what I could do is go put that in... I could go expand the state table, but the reason why that sucks is because then I need to go rerun it from scratch to update the pickle file. Boo! Yeah, so something is very wrong with the revisor. Well, actually, so in this case, we can see the output to the revisor is this, but it shouldn't be modifying that. So in the revisor, it's known bad right here. Let me look at what it's returning from the special agent node in here. Okay. I think that's what's happening. No, all the steps are still in there when it returns back from the special agent node. So, from here to here, there's something jacking it up in the step update. So it has to be in the step update, but what the heck could it be? All right, this is ugly as sin. Well, actually, hold on. I'm gonna back out some of the changes in here. So this part's going to go away. Yeah, I'm gonna back this out. Actually, no, I want to leave it in for just a second. Hold on, I gotta run to the bathroom. I'll be right back. All right, I'm back. Let's see if this green screen works properly. I gotta fix that too, since I swapped to the new camera. Let's see. Black Zillion, what's up, man? Actually, it's up on GitHub. If you want to check it out, it's on the Blaise Bits GitHub. Here. Yep. So let me drop that for you. It is absolute, just smashed bunghole of code. I'm gonna be straight up with you, but it's a fun project. I enjoy it. I'm seeing all the faults with some of the AI agents and stuff. And actually, I was thinking about it. I was trying to think, because everything I'm doing in this project is in LangChain and LangGraph. Why did I pick that? They're popular. No other reason. And they're in Python. So, and I really wanted to learn some more Python. But one of the things that kind of comes up with that is I was looking at Claude Code. We were talking about the skills inside Claude Code earlier. I was completely like out on Claude Code. I didn't really give a damn about it until 2 weeks ago. I took a course with Jason Haddix, and then when he showed me some of the stuff he was doing with Claude Code, I was like, all right, cool. I'll take a look at it. The way I kind of was mapping this stuff in my head from what I knew of LangChain and LangGraph over to skills was I looked at it as the skills are basically just instances of an agent. So what it's going to do is it's basically, if you think like you've got like an agent defined over in Python, each of those skills is just like an instantiated version of that agent. So it instantiates it, spins it up, let it do its thing, and then it spins it back into the main thread. So that's the way I was kind of relaying that in here, is that each of those skills basically correlates to an agent. So it's been kind of cool. I've been tinkering with it. I had some fun doing a little bit of work with it at work, but I'm still trying to figure out because it's got some weird oddities to it. So I definitely am still in the camp of AI should be replacing absolutely zero people right now. But also, I do like to tinker with it and go play with it and see like where it really falls flat on its face. Because being a professional offensive security guy, my clients are going to start implementing this, and a lot of people are just like, we're just going to throw some AI on it and see what it sticks. They're doing the Cave Johnson approach. I'll be honest with you, we don't even know what we're doing right now. We're just throwing AI at the wall and we're going to see what sticks. That's what they're doing, 100%. And so anytime they throw AI on something, I'm like, okay, cool, time to go bust it up. Why? Because that's what I get paid to do. Scientifically bust things up. You know what I actually might want to do here? So we have this last tool call in here, right? All this stuff. Let me take this back out. I got to back this. Actually, hold on. I think I could just revert. Boop. There we go. But I think, oh, dang it. This won't return that. Crap. Because the router function is a little bit different. It doesn't actually directly access the state table. It cannot return to the state table. It just returns a string that tells it what node to go to next. So we can't actually emit changes to the state table from here. But we could take this. We actually could go grab this here. We could do one more thing with this. We actually could track this in the working memory. Oh no, the working memory is only a string. Damn it. All right, I want to do one more thing in here. I'm going to make another addition over to the Stinger state. So we still have our working memory, our long-term memory. We're going to call this our last tool called, and that's going to be I think it's a tool message. Yeah, tool message right here. And then what we'll do is whenever this comes up, we'll go check the scratchpad for that message right here, and we can update that. I think that would work. Oh, sorry guys, I'm trying to keep track of the chat. I'm also trying to keep track of everything that's going on here. I'm still a little bit brain dead because my whole family's been sick for like 2 weeks now. Plague season's in full effect here in Texas. So, but yeah, so this whole project here that we're working on, Ahmed, is a little CTF bot, a little AI bot to play hacking CTF games. So right now we're just testing it. It's still super rough, right? Here's the overall architecture of it. For everybody who's new coming in, This is the main graph of everything that happens. This is all orchestrated in LangGraph. And all LangGraph does is it handles the flow in the routing. Thank you. It handles the flow in the routing and the state management. That's it. So we go through and we define where things are going to get routed to in code, and it handles the state management. And then each of these nodes kind of just returns an update to the state table. The next node takes it in, reads the state table, takes actions on it, makes language model calls, anything like this. Yeah, LangGraph. And so the counterpart to that, which you actually don't have to even use, is LangChain. That handles all the language model interactions. So like when we're making calls over to Anthropic, that's what it's doing. I'm actually pretty soon here going to run out of Anthropic tokens and probably will swap this over to using OpenRouter instead. But anyway, this is the main graph. This is the supervisor here, which is Stinger. And then we're going to have four primary graphs. They're four primary agents. Let me scoot this out of the way because that's nothing. Right now we've got recon and enumeration. They're largely identical. And in fact, once I get all the agents done, I'm going to do a big refactor and cleaning up of the code. We are currently fixing the exploit agent, which used to work, but it wasn't robust enough. So we're trying to add some robustness to it. There's one more agent over here that we're going to add for post exploitation. So interacting with the system actually after we get a shell on it and doing it through a C2. And then we have one more to update, which is the Stinger. Stinger is the supervisor, and right now it's a very dumb supervisor and doesn't do any intelligence on it. We're giving it all the things it needs to do. We're going to take that away and we're going to make Stinger think about what it needs to do to go compromise the box. What is a CTF game? Dude, they're so much fun. The most well-known one is Hack the Box. So Hack the Box here, and they've got a couple of different areas for this, but in the CTF range, it's basically the idea is they're purposely vulnerable systems that have security flaws in them, and the part of the game is to go hack into them, and there's two flags on there. There's a user flag, which is when you first compromise the system, you're not going to have full system or root access, right? So you get the user flag, and then there's some way on that system to elevate your permissions to root, and then once you get up to root, then you can capture the root flag. So there's always the two flags on there. They're very simple. They're usually like a single box. So, but they're kind of contrived examples. I like CTFs, but I think people get too stuck on them, and it can kind of teach you bad habits if you're wanting to work in towards professional offensive security. But they do serve a good learning purpose. I actually don't really care for CTFs personally. I'm not going to belittle anybody for enjoying CTFs. They're like Sudoku for hackers. But I do enjoy the idea of making a little AI bot and seeing how far we can push it to go play the CTFs. What do you have for ban defense? Are you talking about for like worry about getting banned from Anthropic? Oh, I don't give a crap, man. And plus, I'm doing it through the API, so I'm not worried about that. Oh no, dude, this is all of our Python code right here. So LangChain and LangGraph, they're Python libraries in here. So no, I've written all the code in here. There's only been 2 sections of the code that were actually assisted for being written by AI. But actually, I started the project to learn how to be a better programmer. Oh, banned from the CTF platforms? They don't care. They actually have specialized ranges just for AI agents, but that's not what I'm trying to work towards. Yeah. Now, they don't really give a crap. I mean, heck, even I think Hack the Box has said that if you want to drop 0 days when you're doing the CTFs, that's fine. I have a strong suspicion some really industrious nerd is doing that, because if you look at, you can see like when they first drop a box, you can see how long it takes somebody to get first blood on the user flag and first prompt on the admin flag, the root flag. And some of these guys are doing it in minutes, like sub 10 minutes. And I'm like, okay, if they want to go burn an O day doing something like that, totally cool. But I was like, it is wild, bro. Yes. Yes, Ahmed, correct. We're making a little AI agent to go play CTF games for fun. Oh, dude, there's so many languages you can use. Another reason why Python was a big one for me is because all of the work I've been doing on AI and machine learning stuff, 99% of the time, those libraries are written in Python. So I wanted to become a better just coder in general. Now, when I say better coder, what I mean is I've been in IT for 15 years. I had to look at the date. I've been in IT for 15 years. I've been messing with computers since the second grade. My first coding language was basic, like line 10, line 20, that kind of basic, right? And I've been through probably 3 different like introductory courses. But in my day job, I don't really get to build a lot of things. You don't get to say they're written in Python? Dude, a lot of the libraries are though, man. They're written and meant to be used in Python. I know they're written in C and you're actually using C in the back end, but they're meant to be written in there. Yeah. So if I really, really hated my life, I could go try doing this all in C. But I don't. Python has a lot more practical applications for what I'm doing. I have written and hacked and modified scripts in probably a dozen different languages over the last 7 years that I've been in offensive security, because you get access to code, or clients give you code, you've got to go analyze it, find security flaws in it. But actually building something from scratch was something I didn't have a lot of experience with. That's what this is trying to help me think about, is how do I kind of develop a larger code base? I enjoy coding. It's a lot of fun for me. Let's see here. All right, so somewhere in this chain here, speaking of, let me back out the CTF stuff. Let me come back over to the exploit agent. So each of these, by the way, recon, you can see like the entire recon node chain here. It's really ugly in this view, but that's what these are. Each of these are actually other graphs that are executing. So recon, enumeration, exploit, these are other agents that we've got here. So we've got a supervising agent called Stinger, and then recon is a different agent, enumeration is a different agent, exploit's a different agent. We're currently working here on the exploitation agent. So this is the loop we're currently double checking. For some reason, when it takes this path here, the update node completely borks the state table. I don't know why. So that's what we're going to go try and figure out here. Because if we look at the actual agent code, only thing it's writing to is that scratch pad, which is what it should be writing to. It should throw that, basically the last summary message. We've coded this special agent that gets executed here to provide a summary of everything that it did. And then that's what we're going to be tracking. So we're not tracking the individual steps of the special agent. We're just tracking the detailed summary of all of its steps that it gives us at the end. We've put that in the prompt. It's coming back. And it looks like everything is coming back correctly from our traces from that. But, like I said, for some reason when taking this code path, something in the updater completely eats all the exploit steps that we've got carefully crafted and managed and cared for. It's very, very odd. If they tried to use Python for a test load, it would have run through a wall by the time they had finished the object detection. Yeah, no kidding, man. Hey, Noom, what's up, brother? Happy Saturday. Yeah, no kidding. I totally get what you're saying, though. It's like, no, they're written in C, and yes, there's a Python integration wrapper to it. I totally understand that, yes. However, they've made it really simple to go through and do a lot of these things in Python. So there's a lot of other libraries that are available for interacting with the LLMs. So there's 2 that we're using in this. Hang on one sec, guys. Sock's getting on to me. He's like, make sure and drink water. I was like, I am very well hydrated, my dear. Sock is my wife, by the way, the supportive, organized caregiver. Check out the Handmade Hero series by Casey Morai. Let me look that up real quick. Yeah. Actually, that could come in very handy, Ahmed, because, like I said, this was all part of a learning exercise as well. All of this code here. So the code, as it's evolved, has gotten better. Like, for example, I didn't know about the type hinting in Python. That wasn't a thing last time I was coding in Python. But it has made it a lot simpler. It's still got some bugs in it, though, because, like, for example, Scratchpad, it's showing that, hey, it's supposed to be something else. I'm like, no, it's not. You're totally fine. Actually, let me double check that real quick. Anyway, hold on. Let me write this down real fast while you're for your suggestion. Handmade Hero. What's his name? Casey? Because eventually, after we get to the point in the project where... Let me come back up here. Oh god, that is horrible. Why is it... There we go. So after we get back to the point where the post-exploitation agent's done, we're going to come back to the supervisor. Right now, we give it like all these breadcrumbs to go down. And we're going to strip that out eventually. And Stinger's going to have to figure it out on its own. Be like, good luck, go forth, hack and have fun. But after we do that, I'm going to go through and we're basically going to do like a code pause and then start restructuring everything and cleaning it up. So that actually could be super handy. Let me see. Let me pull, actually, we'll just pull this up real quick. Because I fully admit I am a scrub tier developer. It's not my specialty. I'm just trying to get better at writing code because I enjoy it. It's a lot of fun. Let's see. This is to create a complete professional quality game accompanied by videos to explain every single line of the source code. The series began in 2014. Dang, he's been going for a while then. Programming sessions are limited to 1 hour per weekday, and it remains manageable for people who want to practice coding along with the series. Okay, snap. Oh wait, this is the official website. Here we go. Handmadehero.org. Oh, it looks like it's on hiatus or something. Just check it out on YouTube. Okay. The last time I really dug into Python was probably... It's been a minute. I would say maybe 2019. Yeah. I did a lot of JavaScript because we built a prototype command and control system in Go. I say we, really it's two other guys. I didn't actually do very much of the Go programming. But they did the back end. They didn't want to do the front end. I was like, all right, fine, I'll do the front end. I'm hacking websites all day, any day. Anyway, how hard could it be? I learned I didn't know jack about developing front ends. So I have an extra special appreciation for UI and UX development after that. But that was a whole lot of Node.js. And I chose this project to use LangChain and LangGraph. And the only two systems that it's available in is JavaScript and Python. So that also further kind of pushed me over into the Python side of the house. Let me go look this up again. Handmade Hero. Complete. So there's a playlist that came up that's like 696 videos. Damn. That's amazing. Okay, I've got it bookmarked now. Well, I really wanted to do it in Vue.js because originally Deimos was supposed to be extensible and work at a lot of other systems. So I chose Vue so I could use some of the Vue components to make it interactable to other front ends. So yeah, I did the whole thing in Vue.js. It actually came out pretty decent for someone who just didn't really know a lot, and surprised my boss because he's like, hey, where's the front end? Where's your progress on the front end? And I'm showing him like really basic stuff. I go to DEF CON and went to DEF CON. I'm working on all this stuff. And then at night in my hotel room, I'm actually coding the front end. I had learned enough to actually do it. And then I come back from DEF CON. I was like, okay, here's the prototype front end. And it's like, boom. It's beautiful. It's laid out. It's dashboarded. He's like, damn, you did that at DEF CON? I was like, yeah, I didn't go to many of the parties. I just did it in my hotel room. Oh, dude, don't even get me started on the React BS in Windows 11. I was like, are you for real, guys? Come on. Come on, man. Hold on. I need to actually add some lab time real quick. There we go. That'll get us through the rest of the stream here. All right. Let me take another look at this. What is happening here? So what we're doing here is we double check that we do have an exploit task, right? There we go. So we check that the current task, if it's assigned to an exploit, to the exploit agent, we go through, we do all this. We have our nice little else here. All that's good. And then we return all this stuff back. So we have persistent tools and we have our state. Okay. Let me see what this is actually returning in here. Because we're returning messages, persistence tools, and this state. So let's double check that part in the trace here. Okay, so here's where we actually... Okay, so let's look at the exploit node. So for the input state here, we collapse this down. And you were asking, like earlier, was this some GUI no-code BS? No, this is just an analytics system available from the guys that made LangChain and LangGraph. It's called... This is called LangSmith, where I can actually see the trace of like what happened to the state table as it went through. And then this part over here is called the LangGraph Studio, LangSmith Studio, whatever. And it just lets me visualize what's happening to the state table as it's going through. I can see like what nodes are being hit, what code paths it's taking. You can dig through it, but honestly, if you've got a really chunky state table like we do, this isn't super helpful. But it does make a nice little visual. Lets me make sure I've got all the nodes routed correctly. So what you see here, where these conditional, these dotted dashes are, these dotted lines, those are conditional jumps. There's a hidden function in here where the exploit process, the step processor, for example, sends its state table and routes it to a routing function. And then that routing function decides, okay, do I send it to this node or do I send it to this node? So it can take either one of these. But these solid lines, those are hard links. Every time the the tool node completes, it has to send it down to this updater node. Same thing with the special agent node, has to come down here. So this just is a little bit of a visualization to make sure that I didn't code it all functified. Also, it lets me execute the graph here with a specific state table. Now, in this case, I actually made a dirty little hack in here where when it enters the exploit graph, since we're working on it, normally, whenever I first spin this up, there we go. What happens is, if I just run the stinger graph, it still has to go through and do recon and enumeration all over again before it even gets to exploit. So while we're working on the exploit graph, what I did is, I have a function in here that doesn't do any language model stuff, but when it hits this node, it actually checks to see the state of the state table and saves a copy of it to the disk. And then if it doesn't see anything in the state table, it loads that copy from disk. So it's just a dirty little hack to allow me to just rerun this as a quick and dirty time travel. Heard about File Pilot? I have not. Okay, all the steps are still in here. This is the input side, right? Okay, that's our input. Let's go down to the output and double check it real fast again. Yeah, so see this? All the steps are still in here when that special agent node exits. So what this means is, over here, when we're tracking this, when this data gets passed from this node to this node, the data is good, right? We come down, we look at the updater. And then, so now let's go double check the update again real quick. So if we go to update and we look at the input, I'm just trying to make sure I'm not overlooking something in here. And look, we see all the exploit steps that it should be going through. These are theoretically the steps that it should be able to go through to exploit the target. However, we actually have a revisor in here that can go through and make error corrections. So, for example, this target doesn't allow uploading .php files. So the step revisor can notice that and can actually change this entire structure in here. This entire, what is it? This entire structure, well, it doesn't really show, oh, let me just collapse that down. This whole thing is an exploit task. So it's actually nested under a parent task right here. So there's, you have a task and then an exploit task under that, and you have exploit steps underneath that. So we give it the ability to go through and modify, I think, all the steps. No, actually, we let it modify the entire task right here. This whole thing can get updated by the revisor. So when it hits that roadblock of trying to call the special agent, upload the web shell, PHP's blocked, revisor should be able to come in and say, okay, reorder the steps like this. Let's use a rename. I want you to rename the file to something else, and then let it try that. Let's see. Excuse me. Hold on, this is the output, right? No, we're still in the input. Okay, hold on. Collapse that down. All right, I'm going to do something stupid, but if it works, then it's not stupid. So here, for some reason, I can kind of tell where it's happening, right? So hold on, if I come back here, if I look at the input to the revisor, we're going to see the broken state table, right? Let's double check it. Yeah, see right here? All this is just, boop, jacked completely. So what we need to do is we need to figure out what's going on in here. Something with this step update. So here's what I'm going to do. Let's see. There's our step planner, processor, updater. Okay. I'm going to return this again right here. Actually, I'm going to back that out. Let's back that out right there. We're going to come back to this particular one, but I'm going to modify this. So we're going to return that task here, because then we can see like, okay, what's happening with all of this, and why is that one just getting truncated like it shouldn't be? So let me see if it hot loaded into here. Okay, looks like it did. This little heads up message. Yeah, it's because I've got an option set it doesn't really like. And let's go try running this again. So you notice how I submitted that with just a blank object. That means it thinks it has no state table, but when it hits that load pickle in there, it actually loads the state table from disk. Like I said, dirty, cheap time travel lets me skip all the previous nodes and just run this one directly. Hey, Ahmed, did you see what their supposed fix is for speeding up Explorer on Windows 11? They're just going to preload it into memory. They're not going to load it at execution time. They're just going to preload it. Perfect timing for the RAM shortage. We're just going to preload crap into memory for you. Okay, so we hit an error, looks like in the exact same spot, but we should have a little bit better insight into it now. So let's come down to the revisor. And we're going to double check the input real fast. Oh, sorry, I looked at the wrong one. Here's update. So when the state table enters update, there's all of our exploit steps. they're still there. But now when we exit update, excuse me? Hold the phone. Hold on, let me collapse some of this stuff down real quick. There's our task. That was unexpected. Because look, all the steps are still here when it exits update. See that? All the steps are still there. So why is it... Let's check the input to the reviser. This makes no sense. Hold on. So here's what happens, right? Let's look at the graph real quick. So we're going amongst these three nodes right here. We call our special agent node. We go to update. What we can see from the trace here is that from update, our output right here, our update has, or the output has all of the steps right here. See that? Step, 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 step. Everything's good. Everything's great. Everything is there. But now the reviser is saying that when it receives the state table, all the steps are gone. The entire exploit task is gone. And that's the input. Which makes no sense because, like I said, what happens here is from update to reviser, this is a hard jump. There's not even anything in the middle here to try and process between it. It literally says, okay, take the output from this and pipe it to the input for this. What in the heck is going on? So we added this in so we could see exactly what was coming back. All right, just for a sanity check, let me do something here real quick. I'm going to kill the LangGraph server that's serving up that nice, pretty UI. I'm going to restart it. Maybe there's something funky in memory that didn't get loaded properly. I don't know how that would happen, but just as a sanity check, I'm going to do this one more time here. And now here's one of the cool things that we can do. We can, with this interface, is we can actually time travel back to here. So this is saying that the step reviser is returning that. Exploit step update, if we look at it. Ah, damn it. Hang on. I got to get the URL correctly. Because I'm actually routing this through Cloudflare, so I need to... We run this back again here. Okay, so here we go. So here's our update, right? This is what it's returning. What we're seeing here is like what it is returning for us. If we look at the output, so this is saying the step update is the one not doing it correctly. See, this is what we should see. This is a properly structured exploit task here. This here is not a properly structured exploit task. Well, yes it is. So it does still have all the steps. Add step update. Okay. Okay, I'm going to try something. I'm going to try rerunning it from here. So what it's going to do is it's going to initialize this at that node with that state table. And we'll see a very tiny trace show up, especially if it hits the step processor and then dies. Which it looks like it did. Let's go double check this here. This literally makes no sense, though.
I can't hear you. Sound off like you got a pair.
Hey, Gumby, what's up, man? Let me rewind it back one more here. So here's where we ran it previously last time. So we did a fork of it and we ran it again. I'm going to rerun it from here. I'm going to back it up one more step. And this is going pretty fast because these this node is not doing any kind of updates to it. It's not doing any language model calls, so it runs really quickly. So what is going on here? What I missed? What you missed is a lot of discussion about AI libraries not actually being written in Python, but really just C wrappers implemented in Python. And then also, Ahmed was giving me some cool resources to go check out to become a better developer. Which actually I think might be handy because when we get finished with the Stinger agent, we're going to do a complete rewrite of everything and clean it up because there's a ton of optimization that can happen in here. Okay, all the steps are in here. This is our input, right? Yep, there's our input. And here's our output. And our output shows all the steps as well, right? So this is what should be emitted back to the graph. This guy right here. Now, if we come look at the revisor right here, and then let's go dig down again. This is the part that's not making sense, Gumby. Look at that. We've lost all the data that was sitting here. The entire exploit task is gone. Let me try something real quick. I'm going to do something. Annoying debug. I'm going to pull out some stuff from the state table here. So what we're going to do is we're going to pull out the state, our, what is this? Our tasks. And then from there, we're going to get, from the state, we're going to get the current task. And then from that, we want to get the output for the task because that's actually where the exploit task lives. Yeah, I'm going to do an annoying debug on this real quick. There we go. I'm just waiting for it to hot load in the new code. All right, so it did that. And then I believe if I come back here and I rerun it from the end of special agent node right here. I'm going to rerun from here again. I believe it should use the new piece of code there. And we'll be able to find out by watching the terminal. Yeah, there's our annoying debug. So we're going to go check that here in just a second. So it still errors out.
Have you tried turning it off and on again?
I did. Actually, I just tried turning it off and on again, bro. And here's the thing. I can see when it enters here. I can see all of that, right? So look, this is our list of steps right here. And look at this. We have iteration, scratchpad, get the web, and so what it did is it called the dice go. Hold on, where's the task here? Task, get the artifact. But look at this. We can see our here, navigate to the upload form, and then we see, we should see the other steps actually existing in here. Yeah, iteration 0, iteration 0. So we still have all the stuff in here. So something I think is actually jacking up. So we just proved that when it hits the revisor, it does have all the information. So what's happening here? Yeah, I did break it again. Yeah. Hey, Gumby, how does the camera look? Because actually, I had to bypass the Elgato software, and I'm pulling the feed directly from the camera. Hopefully, it looks a little bit better. I think the green screen's looking good, except for over here, there's a little bit of tear in the fabric of reality right around there. But that's just because of the positioning of the green screen. Which is really annoying because I put markers on the floor to know where to put the green screen because I don't leave it up all the time. And it's good enough. Nobody looks in that corner anyway. I'm going to take out some of this code here because I'm not even using it anyway. Step task and task output are not even being used. So hold on, let's go take a look at the language model call. So when we send this to the language model, what are we sending? Okay, so when we send it to the language model, we're sending everything. Look at that. There's all the information right there. And for some reason, the only thing coming back is this stub piece. So it really is something in the revisor. So this was actually something else that one of the guys on Twitter had pointed me to. Not directly, it was just another conversation that I came across when I was scrolling through Twitter. But actually he said emitting an entire JSON is suboptimal. Really, you would want to do like a JSON patch in here. But I've never done JSON patching before. Forehead's blinding you. I'll tinker with the colors a bit later. Right now, I think I don't even have the filters turned on right here. Yeah, that was the way it currently was set earlier. But yeah, there was the that was the color correction earlier, so I turned it off. I'll go tinker with it again. I got a buddy who's a professional videographer, and he helped me with the color correction last time. But since I swapped cameras, obviously the color correction's all gonna be redone. Yeah, it looked pink on my screen actually, and actually as I'm looking on my screen, it looks decent. I actually look like a human instead of like a washout, you know, never sees the sunlight type of guy that I really am. Especially the last 2 weeks. Usually it's not this bad, but the last 2 weeks being sick, it's been rough. All right, so I can definitely see that all the information for the exploit task is coming back right here. See that? So why is the exploit task only returning that? Because the definition that we send it is for some reason this exploit task definition is like not working. So what we may need to do is actually go define this as something for, because we're sending it, let me come over here. What we're sending it is this object here. And it's all annotated, right? Actually, why does it look like that? This should be all annotated for the language model. That was the whole reason why we did that. Oh, yeah, there it is. Everything's still in there. Yeah, see that? So it has all the annotation in there. It's just this tiny window. But look at that. It shows exactly what it needs. So let me look at something real quick. JSON patching. Because this is something I'm not actually familiar with. Maybe we can actually just get it to produce a patch and we can just have it emit the updates to the table. Go away. I do like this meme though. So what's a JSON patch? Expresses, recounts, depicts a JSON document. It applies operations to the document. Operations with its values to be manipulated are also in the JSON document contained in an array. So this is a document. This document is the JSON patch document. Okay. So for example, we got somebody with name, age, gender, and height. And then a JSON patch document is we go to relationship and flirting. Oh, so they're adding relationship status. And then they're going to replace gender with unknown and remove height. So afterwards, we don't have a height. We added a job title. We added a relationship. Go the hell away. Chari, what's up? Might give you a quick recap? Sure. So what's currently happening is, for some reason, so we've done a bunch of debugging, and by debugging I mean print statements in here. And it looks like, from what we can tell, the state table is being passed through to all of these nodes when it's executing the workflow. When that happens, for some reason, the exploit step revisor is getting all of the information, right? So we send it in all this JSON as part of the system prompt. Actually, I take it back. We send it as part of the user prompt in here, right? It calls it human, but really this is like a user prompt. So we give it information about, hey, this is what actually happened. And then we give it information about the entire state of the exploit task. So these are nested. Let me come back a little bit here. The way these are nested is we have an exploit task, and then underneath that, actually, yeah, here we go. And then we have steps. And so the steps are the individual steps to complete the exploit. And then this is the structure of it. So we've modified it. These are just some chicken scratch notes in here, but that's what's happening. So we have a task, and then underneath that task, we have this exploit task, and we have these exploit steps. For some reason, it was looking like the revisor. This makes no sense too. Okay, because if we look at the input of it, let me bust this down. It looks like, hey, this is all it's seeing right here. But I know this is not the case. I know that's not the case. Because when I go actually pull this information from here, there's the actual exploit task. So let me go double check this real quick. Where are we pulling this information from for the prompt? That will help us figure this out explicitly. So our exploit task is our exploit task. So here's our exploit task. We actually go pull it out of the state table. And then we go get the current step right there. So there's our step and our task. So we tell it which step we're working on, and then we give it the entire object of everything. And then the idea is it should return a completely new exploit step that we go slot in there. For some reason, LangGraph is under the impression that all we're getting for this is, and it makes no sense because the node previous to this shows the output as having everything, that all the steps are missing in here. See that? But if I come over to here, the previous node, when it executes, because it goes directly from update to revisor, there's no way it can take any other path. And we look at here, we see all of our nice little exploit steps right here. Get the web shell artifact, navigate to the upload panel, upload the PHP web shell. All this stuff. And to further top it off, we can actually see the entire exploit task in its entirety right here in the prompt. So we can tell that it's getting all the information. There's something weird about how it's processing it. Maybe it's a bug in the LangGraph studio. Wrench, what's up, sir? Yeah, long time no see. Happy Saturday. Roll it back. Dude, it did this from the rip as soon as I loaded it up. I tell you what, let me expand the filter here. Last 14 days. Let me see here. So these are all from today. This was the last one that we ran right here. So this was the one we ran. I missed last weekend while I was... Oh, that one didn't complete because I forgot that the lab had timed out, remember? Let me try this one. So this was the last one that we had. And this was where we fixed the issue with the browser agent. The browser agent wasn't handing off correctly in here. So we fixed that. We went through and we fixed the browser agent. So this node would properly hand off to step update. All that was good after we did that. So now... Yeah, I have to go with this is a bug in LangGraph and how it's tracking it, because it's the only thing that kind of makes sense to it. Because we see the entire setup right here. We can see that it called the exploit task correctly. That should not say the exploit step though. Let me double check and make sure I didn't put a typo in here. Maybe that's what's messing it up. Maybe the prompt is not being processed correctly. It worked before the push, kind of. I don't think this is a purely coding issue though. Hold on. Let's change this. So the exploit tags, this is going to be the, what do I want to call this? The exploit. Let me think about this real quick. So here's our steps. Here's our task. So the task is, for example, let me come back up to here. Let me double check how I kind of structured this. Back it up, back this thing up. All right, here we go. So this is our exploit task, right? And the task is get remote code execution on the shell. Let's see, upload a PHP web shell. How do I want to word this? I think maybe that step, the word step, is throwing all the vectors off. But we don't really have an index for it. So this would be the exploit method being attempted. There we go. That's what we'll say. Because the task itself, if we look right here, is to get remote code execution from a web shell, which we gave it that for now. And we just copied that verbatim from TryHackMe. So what we could do is we could take that. Yeah, because the reason why this is an array here is because we're going to give it 3 tries to make this work. So this could be like basically this first entry in the output could be like the first attempt to do the exploit. And then there could be a second attempt with modifications from the exploit agent. So we're giving it multiple chances here. So I was kind of giving it, I wanted to give it a way to fail and then go back to the drawing board and start from scratch again. Hey, Bobby, what's up, brother? The Bobby Mac Daddy on a Saturday. What's up, dude? I just saw a pop up on Discord. Tyler, if you're still in, that's funny. He's like, hey guys, I got bored. I just made a new lab. Have fun. Too funny. Hold on, let me go pull this up real quick. Because I just saw the pop-up come up on Discord. Let's see. I got bored, so I created a brand new lab that combines AWS and web app pen testing. Sexy. So this one's for subscribers only, but subscriptions are only $6.99 a month. If you like this kind of stuff and you're trying to learn these things, go get a one over on Tyler's setup. Hold on. Let me just pull it up real quick. Let's just pull it up. Static. I'm buzzing with anticipation. You've been assigned a web application penetration test on a client's employee portal. During the scoping call, you also learn the client uses AWS in their website architecture. So in preparation for the upcoming Red Team engagement, your task is to figure out a way to steal credentials from the website when employees log in. Nice. Final flag is the password of the username, Tyler. That's right, we're going to pwn the Tyler. Nice. Nice. Here, I'm going to drop this link up in chat for everybody. There we go. While I was lurking, I made an entire lab that combines AWS and web app. Dude, I've had an Azure and an AWS course sitting on my plate for a hot minute. And then I started working on HackBot, And I need to go devote some time to doing that. But honestly, all the AI and machine learning stuff has really drawn me over to that. And it's not such a bad thing. I really want to work on those skills. I know very little about AWS. I know a decent amount about Azure and Entra. But I have so many other people on my team that do know AWS and Azure and Entra very well. Some just absolute galaxy brains. But not a lot really understand the AI and ML space. So I've still got it on the plate. I'm trying to get to it. I'm having a lot of fun messing around with the AI stuff and figuring out ways to break it and bust it up. This looks really cool. I gusta. Hack smarter, not harder. I still say you can do both. Hack smarter and harder. Let me try something here. So with that minor change, so if you might be wondering why are the types in here as annotated, it's because all of this, when I send this class, because look, this is literally what I'm doing in here is, so we have this exploit task object, or this class, right, that defines the shape of this data. And in here, what we do is we actually bind that to the language model as a tool. So really all the tool calls are is just like formatted JSON coming back. And when this happens, I can tell it the shape of the JSON. Rather than actually being a tool call, I said, create this data structure. Boop, and it just comes back. So when it's annotated like this, all this information is actually being passed as part of the tooling metadata over to the language model. So the wording in here is important. So I don't know if that was going to bust it or not. Let's go examine the rest of this real quick. Make sure I didn't like put something else stupid in here. Shulk, what's up, man? Happy Saturday. Welcome in. Oh, wait, I finished this off earlier. I didn't do the thing. Not sponsored by Jocko yet. Working on it. I have 4 more physical therapy sessions left. And part of that's going to be me taking my workout kit actually up to the PT office and be like, okay, I need you to show me how to do these exercises so I'm not going to break my back again. And part of it's probably going to be, okay, we want you to keep doing these exercises to build your core strength back up. And then you can start doing these exercises again. Because, dude, I'm so flabby right now. Back up to like 240. I was chilling at a really good 225. And I'm like, ugh, hate it. Anyway, let's look at this real quick. Let's see, the exploit method being attempted. Perfect. Current status of the exploit task. Good. Let's see. So the current step, list array index value to show the current. Actually, I have put show in there. I'm going to just say for the current step. List array index value for the current step. Perfect. All right, steps. Let's see. List of steps to complete the exploit task. All right. That should be good. Let's see. I'm going to actually put even that in here. I'm going to make it a list array of steps to complete the exploit task. Target IP, host IP address, and then whatever our initial access exploit, that's going to be the payload for single command execution on the target. That should be blank right now. That gets developed after it completes, before it kind of completes the cycle, it builds that initial exploit or initial access exploit. And this is what we're going to hand off to the post exploitation agent at the end. It's still accessible, Gumby. I double checked it before the stream started to make sure the VPN was still working. You are spot on, Chulk. So what we're doing is I'm building this over in LangChain and LangGraph, and we're using a supervisor model. So Stinger here is our supervisor. And what it will do is, forget about this guy right here. That's bogus. But we have Stinger that's the supervisor that should be coordinating activities between recon, enumeration, exploitation, this is the one we're working on currently. And there's one more coming down the pipe after exploit gets nice and solid. That's going to be post-exploitation. Post-exploitation's job is going to be handling all the activity once we actually compromise the host. including taking the initial access exploit here and then turning that into a full C2 connection using Mythic C2. So a couple weeks ago on stream, actually, and you can go check out the replay on YouTube, we actually went through all of the new developer stuff that Cody, the guy who wrote Mythic, put out about getting started on it. And I'm trying really hard to get this part done because I'm off the week of Christmas. I requested that off, and I was going to have a special daytime stream with Cody for people to come ask questions about Mythic, and I thought that would be really cool, and I thought the exploitation agent was going to be really done. I didn't realize I was going to catch the freaking 5th plague and be out last weekend and be delayed on this. So here's hoping that's still going to come through. I can always get Cody on. It's just a pain to get him on during the day, like during the regular work cycle. Right now, we're kind of in cooldown mode. Hey, Shulk, thanks for coming online, man. Appreciate it. And I hope everybody's having a fantastic Saturday. I had a pretty chill one, aside from my older son, Agent Zero, getting sick. Poor kid. He caught a stomach bug. Oh, that's the Mythic place. Thanks, Gumby. You know what else is big and large? These nuts. That's what. Sorry, I couldn't help myself. What's up, Malachi? Oh, yeah. Oh, yeah. All right. I think all this is structured correctly. I don't know what I clicked to get this up here. Close annotations. There we go. All this looks good from here. So what I want to do now is, one of the very cool things you can do with this interface over here. Oh, wait, I got to drop back over to exploit. Is we can actually time travel with this. So I could pull up the last call that was done. And I can actually just tell it, hey, rerun the revisor from this point right here. And then we can check the trace data to make sure that it actually is using the updated object definition. I didn't check to make sure it hot patched in, unfortunately. Wait, give me one sec, guys. I gotta go take care of something. We'll be right back. Damn it, Gumby, I'm not pooping. I'm back already. If I was pooping, I'd be the fastest pooper in the West. What is this song? Midi Sands Frontiers? I think I'm gonna have to kill that one. I don't know what this one is, but already not feeling it. Right. I was working on building an N8N agent to automate HCTF solver, but it's kind of weak, so I tried to power through it with some maps from Pwn to reverse engineering. Oh, nice. This would be really hard to do in N8N, just because N8N is super powerful, and you can do some really cool stuff with it, but it's not well suited for this kind of branching logic thinking, working through stuff. So, and in fact, I have a small N8N server set up at home. It's not doing anything. I think of ideas for it, and then I find a more optimal tool, and then I just abandon the workflow. So you can do some really cool stuff with it. Actually, there's a neat way Network Chuck showed to integrate N8N with Claude Code. I might be doing that, but actually, because I was tinkering with Claude Code in my current pen test, and it was doing some really cool stuff, but it also had some really weird highly suboptimal quirks. Crying in web enumeration. Hello. Hey, Beams. Actually, I know a bunch of guys that have automated a lot of their web enumeration using Claude Code. Some like bug hunter guys, theme. So that's on my to-do list, but it's really hard for me to get the give a damn to do it because I don't do web apps very much anymore. And also, I just did web apps for a long time. If you get really good at it, you can do some really awesome stuff though, Theme. So if you enjoy it, you're struggling with it, continue on with the struggle because the struggle is how you grow and how you learn. I'm a cybersecurity student. I don't love anything I'm doing in there. Dude, cybersecurity, it has a lot of facets to it. And I was watching a short from Low Level Learning. He was talking about that. If you think about it, a lot of people think of, we have like infrastructure, we have servers, we have DevOps, and then we've got security. They think of it as like this other vertical in there. But really, security is an umbrella. It sits on top of all of those, and then it works its way down the stack. So any vertical you can think of, there's a security component to it. It might be you just have not found the vertical that you like. And there's another stack on top of that. So really, it's like a hamburger on top of a bunch of columns in there.
Incoming transmission from E_Royler. Good day, everyone.
Hey, Euler, what's up, brother? The umbrella's been opened up my pooper, trying to understand bind shells. Hang on, I'll give you an. Now you're talking about like bind shells, like where you get code execution and then you connect to the server and then you've got it, or are you talking like a web shell where you actually have the code running in the web server's native language, like PHP? Maybe it's a jar file. Or what would be another one? Heck, you can even do it with JavaScript. Hello, React server-side components. Basic execution kind. Oh, okay. Dude, bind shells they're super easy. Hang on. I can explain bind shells to you. Let me clear this up. Also, Doc G Money, what's up, brother? I saw your message. I just forgot to react to it. I was like, ooh. Shut up, baby. I know it. Let's see. How do they do Claude Code? Because I've heard a lot about it, but I don't understand giving DevOps agents to dev for specifics. So Claude Code can do lots of different stuff in there. I think Network Chuck even has a good video on it. There's lots of guys that have videos on it. But the main thing you have to think about is really Claude Code is a language model in the terminal. And then you can do things with skills, you can do things with plugins, and they have different effects in there. But really, I've just been tinkering with the skills. And the hard part about the skills has been they're not loading by default. Hold on. This is the part I was just talking about earlier today, is that what should happen is you can Claude Code in your home directory. There's a Claude folder and then a skills folder, and you should be able to have like all your skills in there. And for some reason, there's a bug in Claude Code, which I'm surprised that Claude Code couldn't fix, that they don't load directly. It's kind of weird. Okay, so bind shells. Let me explain this real quick. So you have an attack box here, right? And you got your target box right here. And let's say the target box has like a vulnerable web server running on port 80, right? Here. And let's say you find an exploit onto that lets you upload or do something where you run execution, right? So now whenever you do that, you have started a new process, right? So this is a process here. You started a new process listing on some other port. Maybe it's like 4444, our good old Metasploit favorite, right? It's not doing anything though. It's just sitting there waiting for the connection. So then what happens here is then when you connect to it, you are then passing all those commands directly up to the system to be able to run it. So, yeah, except Network Chuck has nicer hair than I do. But yeah, that's it. That's a bind shell. The converse to this, and I'll do this in orange here, is you have something called a reverse shell. That is it. That is how a bind shell works, man. Yeah, don't overthink it. So yeah, hold on. Let me see. So that's our bind shell right there. It binds onto a port on the server and then waits for you to initiate the connection. Now, on the converse, if you have something called a reverse shell, so a rev shell right here, you do the same path. You come through, you exploit, let's say, a vulnerable web server on port 80 or any other system on there. You get your payload on the system. And then what you do is you actually start up a listener right here. So let's say, again, it's our good old Metasploit 4444. And then when that executes, your server actually initiates an outbound TCP, HTTP, whatever connection back to you. That's it. Bind shells, you got to talk to the server to get your shell on the box. Rev shells, you start a listener to catch that server talking back to you. That's it. Boom, boom. Bam. Bind and rev shells in 60 seconds. Oh, Doc, we're still working on it right now. We're dealing with a weird bit of data tracking, though, around the HackBot, because LangChain is showing us one thing, but we're seeing, or LangGraph is showing us one thing over here in the studio, where it's saying that incomplete data is being passed from here to here, but we can tell as the revisor is actually firing, we can see this complete set of data coming up in the language model call. So we're trying to debug that and work through it and kind of fix it a little bit. Actually, I was getting ready to rerun this, wasn't I? Let me see. I did rerun it. Let me go double check that new one here. So for some reason, it's still only returning this. It's only returning... It set this one to working, but like not everything is coming back. All right, let me go make a modification to the prompt here. Because there was an update, we were originally using Claude 3.7, and Claude 3.7 wasn't following the prompt instructions very well. So I finally bit the bullet. I updated it to Claude 4.5. But Claude 4.5 is meant to work with more agentic systems, and you don't necessarily want all of the information about what the language model is seeing. So what we're going to do here is we're going to add some new stuff to the prompt real fast. We're going to say, you must explain your thinking and reasoning that for the returned tool, for the returned exploit task call. Because we have explicitly told it you have to use the exploit task in here. I thought we did anyway. Yeah, you must always return the exploit task data, exploit task data, right there. And in fact, I'm going to backtick it a bit to draw a little bit extra vector attention, because right here, the output coming back is just the data structure. We don't have any reasoning about why it's only returning partial data instead of returning the entire chunk. It's a pain in the butt. Hey, Club, what's up, man? I'm trying my hardest not to cough into the microphone. I apologize, y'all. Oh yeah, Euler, so you figured out the DP API, or as I like to call it, DPAPI issue with decrypting those credentials in Windows. How'd it go? All right, let me make sure that change hot loaded in. Yeah, looks like it did. So I'm going to try running this one more time with our updated. So rerun. The good news is this saves us a bunch of tokens by being able to time travel like that. I did get a shorter alert
Incoming
message.
transmission from E_Royal or DC isn't providing the service to decrypt the creds.
So it wasn't you, it was a lab issue. What basic skills are required to learn LangGraph AI HackBot Dev? Really, if you understand Python and you kind of understand how language models work with data flowing in and out, then you're in a good place to do that. LangChain just handles the interactions to make the language model calls. LangGraph only handles the workflow. So all of this is the LangGraph stuff in here. This part right here, where we've defined the prompts, and up here where we're actually defining the calls to the language model, this section, all that is LangChain. So there's a very clear delineation. LangChain talking to and from the language model. LangGraph handling all the workflow and the state management. And if you know some Python, then you're Gucci. Well, aside from like any of the security information that you'd have to know, but yeah. Hold on one second. I got on a rant and I missed some of the chat messages. Gucci, what are we, 12? Dude, I didn't realize how old I was, Tanis, till one of the guys on Twitter was like, hey, do you remember when you used to have to call a special phone number for like the weather? I'm like, dude, I'm so old, I remember, hello and welcome to Movie Phone. I remember that. I had a phone, used to back in the day, before all the movie theaters put everything online, there was a phone number you called, and you give it your zip code, it would find the nearest theaters, and then you could figure out what was playing at the theaters. God, that was old. That made me feel really old. I'm right there behind you, Tanis. Next month, I'll turn 42. So in theory, I should have the answer to life, the universe, and everything. All right, so can you walk me through the basic idea and logic flow so far? Sure. So let's back this up a little bit. So Stinger here is our supervisor. And his job is to eventually, right now it's very dumb, we give it all the information. But Stinger's job will be to develop, we'll give it a target. We'll say, hey, there's your IP address, go forth and hack. And then it will develop its own plan on how to accomplish that. So it will come in and it'll say, okay, well, first thing, let's figure out like what ports are open. Okay, Recon can do that. All right, now let's figure out what's running on those ports. Okay, we can have enumeration do that. Oh, we see there's a web server running on it. Let's enumerate the web server some more. Boom, so it goes, sends it to enum again. Eventually, when it thinks it's gathered enough information, what it should do then is route to the exploitation agent and say, I want you to exploit this server in this way. And then after that, once the exploitation agent finishes, its sole job is to create an initial access exploit. And that is a single script, line of code, tool call, whatever, that lets us get at least one command to execute on the system. That is then going to be passed over to the post-exploitation, which will live over which I haven't started working on yet because we're still trying to work on the exploitation agent. And then once that's done, the post-ex will handle taking the initial access exploit, upgrading it to a C2 connection, and then all further activities on the host will happen in that post-exploitation agent. So it's going to be the chunkiest and the biggest. It's going to be huge. So after that is done, we're actually going to circle back over to Stinger and then make Stinger intelligent. Because right now, Stinger is purely in code. It doesn't use the language model for anything. We're seeding it up here with this user input and the initializer. It goes through and gets started with everything. So that's how we're going to eventually kind of work back in here. Once Stinger's done, then we'll actually kind of go back and rewrite a bunch of the code because there's a bunch of optimization that can happen in this. Excuse me. And see, what's weird, Tanis, is I don't even feel like a millennial. Because I grew up with my brothers who are, my youngest brother's 5 years older than me. So he was Gen X. My older brother over than him is still Gen X. And those are the two I grew up with. So I feel more like I kind of relate to that. But at the same time, there's a lot of statistical normality that I hit for what millennials actually encounter. All right, so let's see what it comes back with. So it comes back with this right here. All right. So let's see what it came with. So I'm going to analyze the current step and determine the appropriate updates for the exploit task. Analysis. Current step index is 1, which is navigate to the upload form. Scratchpad review. The agent called the browser agent to navigate to the URL. It successfully navigated. page loaded and displayed with a upload data, and the browser is now at the upload page waiting for the next steps. So success criteria, the step task was to navigate to the upload form, and the scratch pad clearly shows navigation was attempted, the page loaded successfully, and the upload is present. So the task completed successfully. Update required. Mark current task index as 1. Increment current step from 1 to 2. Set. Okay. So set the step at index 2 to working. Okay, I get where it's going with this now. At least I understand what it was trying to accomplish. But it should be returning everything in here. So maybe we need to look at using that JSON patch instead, where we can tell it, hey, by the way, here's... Because we send it the entire exploit task, the whole kit and caboodle right here. And what I wanted back was an entire exploit task. However, maybe we just need to actually add more data to it. We already tell it has to use the exploit task as to structure its output, but it needs to be full and complete with no missing data. Maybe we could just add that into it. Hey, Club, no problem, man. Dude, I have a lot of fun with this. This has been a very fun project, if annoying at times. I would rather solve these kind of problems than trying to solve some really weird, like, off-the-wall CTF style challenge. To be perfectly honest.
Let's echo 23, see what's up.
I'm trying to echo 23, brother. Let's see. Where's the scope set and what allows it for what's allowed and not to? So basically, that would be information that eventually would come through as part of the user input, and we tell it like, and there's a value in, where is it? Down here in the states, where we tell it what the target is. Oh no, the context. So the context here would actually be, I don't know why I put a host in there, but the context should actually be something like, hold on, better place to look at it, up here. So like, for example, in here, the context we give it is target machine address is this. So then we would tell it, okay, here's where the scope is, and here's what you're targeting. So right now, it's only designed to work on single target systems. Eventually, we will expand it, and I've been coding it with some of that idea of where we need to expand it to handle like multi-target labs like Game of Active Directory. I'm so looking forward to that too. Recently started the grind on the fundamentals for Hack the Box, so once I get through level 15 of Bandit, nice. I do like the new learning methods they've got. Let's see. Do you think you can get agents to do Pwn and Rev? I don't know. Eventually. That is the idea behind the special agents, is that eventually the special agent should be able to hook into Recon, Enum, and the other ones in there. So, hey, Gumby. Gumby, I did finally mod you, by the way. So you've got all the mod powers. I'm already watching. Actually, you're not modded on YouTube. I gotta figure out how to do that. Curmudgeon's the word, I believe. Get off my lawn, damn kids. What's funny is I can't even chase kids off my lawn because it's sloped like this, like really steeply. You can't even really play in the grass. Oh, let's see here. Let me think about this real quick. So, let me pop back over to the exploit agent. How much time do we have left on the box? We should have plenty. Yeah. So let me try, I'm going to try updating the prompt here. Actually, let me see if anybody else has actually done this. Let's see. JSON patching for LLM responses. Because what we would need to do is we would need to be able to give it a tool that it could use to create the patch. And I don't know how I would structure that tool. Did you figure it out? No, I used prompt engineering. Let me see what this guy says. Let's see. So stitching giant JSONs together with a JSON patch. Okay. JSON's everywhere now. Yeah, I get that. Okay. So we could do a JSON patch or a JSON merge. Let's see. So he's using a Go example here. We might have to find like a Python equivalent to it. Actually, let's look for something a little bit more explicit here. JSON patching, LangChain. So this is in LangChain.js, boo. Python. I've had enough JavaScript to last me a lifetime. Which is funny I say that actually because I was looking at Daniel Miesler's personal AI infrastructure, and he's got a lot of really cool skills in there, but they're all built in JavaScript or TypeScript, one of the two, because he's using Bun to execute them. And I get his reasoning for it, I just hate it. JSON output parser. Hold on. Why is it not? I guess that was in the older version of LangChain. Heard about a new data structure ordered by AI models and more cheaper than JSON. It's called Rune. I think that was Noon, wasn't it? Was that it? Or wasn't it Noon? I forget. Yeah, but actually, if you really want to get trickier, what you do is use VSC output. Let's see if I could find it. I'm not a... Come on. Really, the test should be if you fail the captcha, they know you're a human. Anyway, it was a meme output. So there was one, I think it was called Toon, actually, now that I think about it. T-O-O-N. Yeah, but it was a type of, it was supposed to like, hey, like really compress the output and save you on some output tokens and whatnot. And really, one of the folks over on Twitter had the better take on it. And they actually made a meme output format called VSC, variables separated by commas. And it was just it was completely a meme. And then it was funny because it blew up on LinkedIn. Everybody's like, oh my God, Source, new output format. And it was a total ripoff. It was just memeing on CSV. Yeah, it was freaking hilarious. It's like the AI slop is real. I'm trying not to make slop. I'm just trying to make goulash. So I did see something though in here where it said, now the current version, let me double check. Because I'm not operating on the latest and greatest version of LangChain. You okay, Peaches? Oh, it's okay. You're okay. It's okay. It's okay. Shh, calm down. Poor Peaches. That's my Boston Terrier, and she got a little, squish nose, squish face. She gets what I call a snortle. It's when the snort gets stuck, and she's like starts breathing real heavy. I was like, oh. Try not to laugh here. All right. Oh, hey guys, by the way, let me grab a link to the, I'm just going to grab a link to the Discord message, because if you're not over on the Hack Smarter Discord, you should be anyway. But I'll drop it here in the chat for y'all. So go check out Tyler's Discord over for the Hack Smarter peeps. And he's doing a free trial right now. So go check that out. No, that's the wrong button. There we go. Extra high. There we go. Let me see here. So I think what it's doing, I was looking at the Pi project Tommel. Where is this? Actually, no, I need to look at the lock file. Where's my lock file? Poetry lock. Let's see. I don't know why this says happy eyeballs. Oh, that's the package. Okay, hold on. Let me see. Let me see which version of LangChain core I'm actually running. Yeah, so I'm actually running 3.2.7. They're actually up to 1.0 now. I'm not going to make that jump until we get finished with the supervisor agent, because it does a lot of code breaking whenever you run through that. Let me see. LangChain 0. Crap, what was the version? Just had it. 0327. Let me see if this has it. That's our JSON tools output parser. Where did I see that though? Let's see. Yeah, so that should be from JSON output parser. So it's streaming. If diff is set to true, it yields a JSON patch operation. I guess we are set to streaming mode. Hold on. We should be able to check that in the metadata though. Excuse me. No, we're set to streaming false. So why would this be returning? Because it's not quite returning. It's returning a mixture here. So it's returning current step, status, and task, right? That's all it's returning, and it should be returning so much more than that. So it's returning the current step, right? And it's returning the task. Maybe it's because task is overloaded in here. But see, it's also, there's several things that it hasn't returned yet. All right, I'm going to try one more thing before we wrap up for tonight. I'm going to modify the prompt a bit more here. So in here, we tell it you must always return the exploit task data. I'm going to tell it one more thing, which is exploit task should be a full and complete copy
so files are big. It takes
of
like
the
50
data
megabytes to store 4 minutes
with
of data.
updates.
But if we delete everything that the brain
I want to see if we can prompt engineer our way around this.
is what processes all the stuff that you get through your ears.
In fact, I'm going to put one more in here.
So the first thing is
So I try to usually keep the prompts pretty skint, but I do go, as we run across issues, that's one of the first places we try to address them. So this guy existed because we were having so many corner cases we kept running into. Let me see. What else do I want to tell it?
one of the first things I'm going to demonstrate is called the missing fundamental. So all sounds are made up of sine waves, and there's a
Incoming transmission from Marano Gumby. This is my nightly reminder. Do forget to push it real good.
Push it real good. I will, buddy. Here in just a minute. Because I want to try running this again. Never return a patch. Always return a... Actually, I'll just tell it. Never return a JSON patch. Okay, so after that hot loads, I'm going to try running this one more time. Did that change it? I hope it did. Let's go back here. We should still be able to time travel this sucker. Yeah, so we should be able to rerun from here. Nope, it's still just returning that partial output. See if anybody else has run across this issue. So LangChain can return a partial output for data structures when using output parsers in streaming mode, but we're not using streaming mode. Are we not? Hold on, because I can see the data streaming in, even though the metadata for this said streaming was set to false. See that? All right, so we're going to assume that's wrong. Particularly with a JSON output parser or Pydantic output parser. So when streaming is enabled, the parser yields a partial JSON object containing all the keys that have been returned, allowing for incremental processes of language model output. So this behavior is especially useful for real-time applications where immediate feedback is needed. So if the diff parameter is set to true during streaming, the parser will yield a JSON patch. All right, let me see if I can, maybe I could just modify this and we can explicitly tell it to yield us a diff. I gotta remember how to do that. Let's see. LangChain, set diff parameter. I misspelled parameter. Parameters. Diffbot. What the heck? Because according to this, it says that the diff parameter was set to true during streaming. Hold on. Was there a diff parameter in here in the metadata? No. What is this diff bot thing? Covers how to extract data from a list of URLs using diffbot. Okay, that's not what I'm looking for. Let's see here. Excuse me. So the diff parameter defaults to true. However, the parameter is not directly applicable to the invoke method of the language model itself, which that is what we're using right here. Because we do an invoke with retry. So while the diff parameter is relevant in the context of streaming logs via a stream log, it's not a parameter that can be directly set for the language model. Okay, so it looks like it is streaming it right now. So we need to know how to handle that. Let's see. How do we handle JSON diffs? So in this mode, instead of yielding complete JSON objects, it yields a JSON patch operation that describes the differences between the previous and current parsed output. So this allows for efficiency. Yeah, excuse me. Got that. Okay, that's something specifically for LangFuse. Is this something I need to actually do with... Maybe I actually need to pass it to the JSON output parser for this. In core. All right, there's the JSON output parser. Okay, so here, I think that's probably what we'll have to do. And unfortunately, I got to wrap it up for tonight, but when we pick it up tomorrow, we'll go implement this JSON output parser with diffing. So in streaming mode, whether to yield diffs between the previous and current parsed output or just the current parsed output. Maybe this is what we're going to need to do, but we'll have to investigate that another night. Let's see if anybody's over on InfoSec streams. Nope, just us. Just us wee nightly hackers.
Incoming transmission from Marano Gumby. Love you long time. See you next time.
Love you long time, Gumby. All right, let me see. I was just gonna say nightly push. All right. So those code changes are up on GitHub now. Eventually, I will migrate off of the. What is it? Eventually, God, I can't wait for this cough to be gone. Eventually, I will migrate off of the HackBot repo, and once it's actually like ready for somewhat public consumption, that's probably going to be quite a while. By the way, over on Twitch, if you have any raid suggestions, feel free to shout them out. Oh, is Sid on? Okay. Heck yeah, we'll go right over to Sid. Yeah, we'll go hit him up. Guys, do me a favor. When you get into Sid's thing, just drop some Hack the Planets in there with some Cookie Monsters. Legally distinct, but identical Cookie Monsters. So, all right, that's where I gotta stop coughing. It's killing me. Take care, everyone. Fucking, I'm dying. I'm dying. Chari, thanks for coming online. Everyone, you'll have a fantastic Sunday tomorrow. Spend some time with friends and family. Get ready for Crushing It mode on Monday. I am going to go clean the kitchen before I go to bed because Sock is very sick. I want to make sure I can help her out as I can. But that's all I got for you guys. I want you all to all take care. Like I said, spend time with your friends and family tomorrow. Get ready for Crushing It mode on Monday. And remember one very important thing, and that is, I love you. Peace.